So same when it comes to your big data. When someone looks at the word called big data, they have their own perspective, like how Shankar has got his own perspective, Baban has got his own perspective towards big data. So if everyone starts having their own perspective towards big data, then it is tough for us to exchange information or the details about big data. That is the reason why industry has standardized the definition for big data. And even as a matter of fact, if you fail to understand what is big data on its own, nothing wrong, that this term you divide into two parts, you try to understand each, then together we can understand easily. If you fail to understand big data at once, then it's good that it is a divide and rule policy that what Britishers has applied and was able to rule the entire world for centuries together. The same policy, divide and rule. You try to understand what is data, and then you can easily understand what is big, and both you put together, you understand easily what is big data. And I think you are definite that what you mean by data. Maybe you may not be in a position to exactly define what is data, but you are definitely aware what is data. Before we talk about data, it is good that we see, have a look at this slide. You understand? I hope you are able to see my desktop. You are able to see my presentation, my slide?
Yes. Yes.
So you look at this one, then you understand data, and in a given context, you churn this data, you process this data, you get information, and you churn this information further, it gives you knowledge. You churn this knowledge further, it gives you wisdom, and with your wisdom, you are able to make the right decisions so that you can put your organization in the right track. The future of your organization depends on your decisions. And decisions can be made only based on the wisdom what you acquire. And wisdom is achieved through the knowledge, and knowledge is gained through information, and information is acquired only by processing data. So we can clearly understand one thing. Data is the base for the future of the organization or the future of anything. If you don't have data, you will not have information. If you don't have information, you will not have knowledge. And if you don't have knowledge, you will not have wisdom. If you don't have wisdom, you cannot make the decisions. And if your decisions are not up to the mark, then the future of the organization will be bad. So we have understood clearly that data is very important. Data is very important. Not only important, is also very essential. I hope you agree with my point. So when data is very important and essential, we need to have an understanding of what exactly data is. You can define data in multiple ways. And this is what the other thing that you can understand. This diagram is intentionally shown for the reason you have more data, the same will not come to the information level. You are going to churn that. You are going to process that. When you process, it is the same thing like, you have 100 liters of milk and you will not get the exact curd, and from curd you will not get the exact volume of cream, and from cream you are not going to get the exact volume of the next level of products. Same like, but that's what I mean by churning. So you have data, and when it is being synthesized, you get information, knowledge, and wisdom. And with wisdom only you are going to make the decisions. So this is the triangle which shows you clearly. You have more data, and from that you get some information. From that you make knowledge, and from that you gain the wisdom. And when it is being, as we need to define what is data, I tried my best to share with you. Data is raw, unorganized facts that need to be processed. Whereas information is when structured, or presented in a given context so that it is useful, that is what we call it to be information. Data is raw, unorganized facts that needs to be processed. Whereas information is something which is processed data, is organized, structured, or presented in a given context so that it is meaningful. That is what we call it to be information. And you see the example, each student's test score is one piece of data, but the class average score or the school average score is what I call it to be the information. With this information only, the class teacher or maybe the school principal is going to take the appropriate decision. What is the class average score or what is the school's average score? Based on that only, the respective people can make the right decisions. That's what I can talk about data and information. So when we know what is data, it is a time for us to talk something about what is big data. To the same data, if you add the word called big, it becomes big data. To the same term called data, you add the word called big, it turns to be big data. But as we need to talk about this in a systematic manner, industry has defined big data with 3 essential characteristics. Like how, when you define a good citizen, you are going to identify the essential characteristics what a good citizen needs to have. Same like, industry also has formulated that with 3 essential characteristics, you are going to define big data. Out of which one is volume, the second one is variety, and the third one is velocity. These are the 3 essential characteristics with which you can define something called big data. The reason why I'm talking more about big data is for the reason big data and Hadoop has got very much relation. Until and unless you understand big data properly, you never understand why we need to learn Hadoop. We understand why we need to learn Hadoop only when we understand what exactly big data is. Of course, these days, industry is slowly extending these. This is called 3 V's. 3 V's. Volume, variety, and velocity are the 3 essential characteristics with which we define big data. And these V's are getting extended. These days, you have something called value. You have something called veracity, you have something called viscosity. So these V's are getting extended slowly. But the first 3 are the essential characteristics which big data needs to have. And you see closely, you understand. This is what I mean by big data. Big data is anything which has got 3 characteristics: volume, variety, and velocity. When it comes to volume, now even your personal data storage on your desktop growing beyond the GBs. That's the reason why now 1 TB hard drive to your laptop or maybe to your desktop has become quite common. You can imagine 2012 January 1 till 2012 December 31st. Just have a overlook on the data that you have collected from different sources onto your laptop, the documents that you have downloaded, the songs that you have downloaded, the pictures that you have taken through your cameras, or the video that you have taken through your cameras, and the other things that you have downloaded from the internet. You calculate how much you have gathered, and from January 1, 2013 till date, if you see what the amount of data that you have gathered, as an individual I'm talking, definitely you might have crossed the volume of the data what you have gathered previous year by this time itself. Individual level itself, when the when the data volume is getting increased year by year, month by month, day by day, when the volume of the data that you are gathering is getting increased, you need not talk much about the corporates, how the volume is growing, exponentially growing. And when you talk about variety, days are gone where you find that entire data is available only in the structured form. As a matter of fact, if you see the statistics, only 20% of the world data is available in the structured form. I mean, which is stored in your relational databases. Remaining 80% is either in the semi-structured form or unstructured form. More varieties of data, different varieties of data coming into your day-to-day life. The varieties of data that is coming into your life, and the velocity, the third characteristic to your big data. So we talk in detail about volume, variety, and velocity, and this is what I thought of showing it to you, what I mean by volume. So compared to the books what you have in your shelf, the books what I am trying to show you here, bigger in volume. Compared to this geography, this is bigger. So it is always one thing that you can understand. This is a relative term. There is no absolute definition for volume. All based on a specific context. You see how data is being. Your 1024 bytes put together 1 KB, and 1024 you keep adding, your data is growing. 1024 TB puts together 1 petabyte. 1024 TB puts together 1 petabyte. And 1024 petabytes, 1 exabyte. And 1024 exabytes is 1 zettabyte. You see the growth rate of the world data in 2011 and 2013. By this time, I think, they have estimated that by 2013 it is going to be 3.6 zettabytes, but it might have surpassed long back. You might have crossed 3.6 zettabytes long back. It's only the estimation. Any of you has idea what is beyond zettabyte?
No.
Beyond zettabyte is yottabyte. 1024 zettabytes put together 1 yottabyte. 1 yottabyte. And why we need to talk about the volume is for the reason, if you see closely, the data that is available to an organization is growing day by day. That is what being shown by me with the upward arrow. And the data that the companies or the organizations able to process is coming down day by day because of the infrastructure what is available to you. So when data coming into your organization is growing day by day and the ability to process the data is coming down, you always will have a gap in between. That is what we technically call it to be blind zone. Why we are worried about the blind zone is for the reason, till you process the data, you should treat that there is gold in that blind zone. I think you agree with me, Shankar. Till you process the data, you should treat that there is gold in that. Because you never know what is the information that you have in the data, then you cannot say whether it is useful or useless. You will come to know only when you process that data, you will come to know whether that is useful or useless. So till that time, you should consider that to be gold. And your goal now is to, what is the goal is? The goal is how this volume of data can be processed. Volume. How this volume, the volume of the data that is coming into your box, how this volume, the first target is how this volume is going to be stored. Forget about processing, how this volume is going to be stored. Once you are able to store, then we think about how we process this. So the target to us is, as part of big data, we have clearly identified that the 3 essential characteristics. 1, your volume, which we have observed now, what we mean by volume. And the challenge here is how these bigger volumes of data are going to be stored. how we store these bigger volumes of data. I mean, the data that is beyond petabytes or beyond exabytes or beyond, your normal storage limit on the servers. How these bigger volumes of data going to be stored? That's what the big challenge. We will talk about the solution a bit later, but this is what the challenge you have. Now, when it comes to the variety, you have all these varieties of data. I'm trying my best to show you the varieties of data that is known to us, but beyond this, you have thousands of varieties. There are many proprietary formats of data which are being used only by the organizations internally. And alone in the image format, if you see, you have GIF, JPEG, PNG, BMP. In the movie, you have MPEG, you have AVI, WMV, and you have WAV, MP3, MP4. In one specific category, you have again different formats. Now, my second big challenge is how these varieties of data are going to be stored. Because your traditional database is going to store the data only if it is available in the structured form. No doubt, if your data is structured, it can be comfortably stored inside your databases, and you can retrieve executing some queries against that data set, and you always can access it. But if your data is not structured, how that data needs to be stored? That's what, again, one more challenge. So you see closely these two things. You understand volume and variety are the two characteristics which are related to the concept of storage. And as part of the big data definition, we have already observed the third V is called the velocity. So can any of you tell me what exactly we mean by velocity in the context of data part?
How fast we can process raw data into a useful information?
Can you be a bit loud?
The time period that we need to process the raw data into useful information.
That's a good thing. Velocity is a characteristic that is attached to the big data. Let me give a statement like this. You have the moment you got from the bed, you have switched on the TV. On the TV screen, someone reading the news saying, there was a heavy rain in the city yesterday, or at a specific place in the city. There was a heavy rain in the specific part of the city yesterday. That is what he or she is reading on the screen. It doesn't sound good because we already enjoyed it. Yesterday we were there in the city and we enjoyed that heavy rain. No point in listening to the same thing. Yesterday there was heavy snowfall. There is no point in, there is no fun in listening to that one because we have already experienced it. But it really sounds good if someone reading on the TV screen telling, tomorrow morning between 10 and 11 there will be heavy snowfall in the specific parts of the city. It really sounds good to listen to that, because tomorrow morning between 10 and 11, if there is heavy snowfall in the specific parts of the city, accordingly you are going to plan whether you need to go to that place, or you need to, if you need to go to that place, how you need to be prepared, or you can postpone that. So you'll be planning in your own way if you know that tomorrow between 10 and 11 there will be heavy snowfall or there will be heavy rain. That's what I mean by velocity. I think you are able to see that one here. From different weather points, from different sensors, the weather information is being collected into your box. If it takes 24 hours for you to process the data to give the results to the customers, by the time you share the results with the customers, the disaster has already happened. When Velocity is the characteristic which is related to the concept of processing the data. How data is coming into your box, at what speed it is coming into your box. Your infrastructure must be in a position to process the data at the same speed so that the results can be shared with your end users. So velocity is a factor which is related to your processing part. So I think you understand what I shared here. This is something called processing. Something related to processing. So velocity is a factor that is related to processing. Now, in terms of big data, you see closely, you have came across three things: volume, then you have variety, and then you have velocity. And these again, first your volume and variety are related to your storage, and your velocity is related to your processing. There are many platforms available in the today's IT world which can address your storage needs. And there are platforms which can address your processing needs. But these are the independent platforms which are specific only for your storage. They are well suited for storage and they are well suited for processing. But you require a solution or you require a framework which is capable of handling both your storage and processing. And one such open source solution is your Hadoop. Hadoop is an open source framework which comes with two parts called as HDFS, Hadoop Distributed File System, and you have something called MapReduce. Your Hadoop Distributed File System is a distributed file system with which you store your data. Large volumes of data and varieties of data can be stored using your HDFS. I talk about HDFS a bit later, but HDFS is primarily targeted for storing your large volumes of data which are available in varieties of forms. And your MapReduce is the programming model which is targeted to process your data with the help of massive parallel processing. So you have two things now. As part of Hadoop framework, you have HDFS, primarily targeted for storing your large volumes of data available in wide varieties of forms. And you have one more framework, that is MapReduce, which is actually targeted for processing your data, which is stored on your HDFS. So this is an open source framework which comes with two parts or two sections. One the MapReduce and the other one my HDFS. So you find literally rare to have one single framework which address both your storage and processing needs. You have very good number of solutions specifically for storage and quite good number of solutions for processing your data specifically. But having together in the same framework is a rare combination. One such rare combination is your Hadoop. So now I think you can clearly understand by this time what is big data and what is Hadoop, in what way those two are related to each other. Can you now tell me at least what is big data and what is Hadoop? So I think by this time I can confidently tell you now, big data is something related to the aspect of problem definition. Big data is a problem actually, problem statement, or you can call it to be a problem definition. And this problem definition is being addressed using the solution called Hadoop. So Hadoop is the solution for your problem called big data. So now I think you can correlate these two things very easily. Big data is actually a problem, and this problem is addressed using the solution called Hadoop. And how Hadoop is going to provide the solution to big data, because we have already discussed volume and variety are related to storage, and velocity is related to processing. So your storage is addressed using HDFS, and your processing is addressed using your MapReduce. So Hadoop is a solution to the big data. So big data is problem basically.
So, Venkat, can I say this time that till the time Hadoop is not into picture, big data is just the raw data, and in order to process this raw data into some useful information, Hadoop is a kind of tool which helps actually in converting the raw information into some useful information.
Absolutely, absolutely. So if you see closely, Hadoop came into picture only after big data.
Right.
Because industry might have defined big data at that time, but they are experiencing it. They are experiencing big data, and as a result of that, the proposals coming and trying to find out the solution, and Hadoop is one best solution. But I can say one thing: big data is known to this world long back. Big data is known to the world long back. You say you take Google into consideration. It is always a wonder to me some time back how your Google is able to process your query and give you all the listing of the websites which matches with your given inputs. As a matter of fact, Google has implemented this Hadoop kind of solution long back. But all those days it was a proprietary solution only being used by Google internally. Later on, of course, Google has made it public. The MapReduce framework, what they are using internally for processing or churning the data. They also exposed to the world called Big Table, how data is being actually stored. The same Big Table what Google has introduced to this world is now in the form of TechyBees in your Hadoop. So this solution was already there with Google, but it was only the proprietary one, which is exclusively used by Google only all the years. But now the same solution can be used by any small corporate company, because Hadoop is an open source framework which can be used, and more specifically, this framework can comfortably run on the commodity hardware. You come across the term called commodity hardware. Whenever you read any document related to Hadoop, you come across this technical term, commodity hardware. They specifically mention commodity hardware for the reason, unlike your traditional databases, like your RDBMS, take Oracle or any database, and you require definitely expensive hardware for it to be installed and for it to render the service. You cannot put your database on a normal hardware. It should be on expensive hardware. When it comes to Hadoop, it is not essential that you require high-end servers to actually form a cluster. Your normal hardware, commodity, I mean your normal hardware, your regular use hardware will be sufficient for you to set up the cluster. So I talk about the cluster and all those things in detail, but I want to make one thing very clear to you: what is big data and what is Hadoop, and how these two are related, and in what way you use big data in the Hadoop space and Hadoop in the big data space. That needs to be clear to you. That's what my first goal. I feel I was able to give you the big insight of the first section of my demonstration. You have any questions on this? Please feel free to ask me so that we can move on to the next discussion.
So for Hadoop, is it right to assume that Hadoop is one of the solutions for big data?
Yeah.
Okay.
So as of today, Hadoop is the only choice, but never knows in the coming days what other things you get, because Hadoop is picking up very fast and it is taking new dimensions. Now you have the second MapReduce version that is called Yarn, yet another resource negotiator as part of your Hadoop framework itself. So I don't think you will get a new framework which is going to address any gap that is left by Hadoop. So any gaps there in the existing version been filled and been released with the new version, it is going ahead. But only thing is, the same Hadoop, the same open source framework is being adopted by different companies like Cloudera, and you see Hortonworks, and you see IBM. IBM has released their own big data bundle. IBM releases the big data bundle, the Hadoop in the form of CDH, and Hortonworks HDP, and IBM is releasing in the form of IBM Big Insights, and Amazon has got their own bundle. Mapr has got their own bundle. Like every corporate is coming into this space, but ultimately all these corporates are using the same open source Hadoop framework as an integral part of their. They're not even doing any modifications or enhancements. The only thing what they're doing is they're integrating all the components of Hadoop. Apart from HDFS and MapReduce, you have the other components like Pig, Hive, Scoop, HBase, Mahout, Avro, Ambari, Zookeeper. There are many other, more than a dozen components you have as part of Hadoop space. All these components are being integrated into one bundle, and that bundle is being released by these corporates. That's the only thing they're doing it, nothing more than that. But it is the same Hadoop open source framework that is being used by all these corporates. IBM Big Insights, this is called IBM Big Insights. So every corporate, Amazon has got their own storage service that is called S3, simple storage service, and their own processing framework. But it is only just a wrapper on the top of Hadoop to give a different look. It is the same chocolate, but the wrappers are different. It is the same chocolate, but the wrappers are being different. So it looks that, you have different solutions for big data, but for all these solutions, the backbone is the same open source framework, what you're seeing here, Hadoop. So in that regard, I can confidently say Hadoop is the only solution for big data at this stage, at the core level, but being provided by different vendors in different flavors, but the solution is the same. I hope this is clear to you.
Yes.
If this is clear to you, I
Srini, so
yeah, please.
Hadoop, right?
Yeah.
What is I know we said Hadoop is the storage and also MapReduce, right? But what is exactly what I'm trying to understand is there a product that has multiple components?
Yeah.
Or is it a software? Right. What is exactly Hadoop is? Yeah.
So you can treat this to be in different ways. Again, it is the perspective. Hadoop on its own is actually a software framework. Hadoop is actually a software framework. Like how you have your, it's a software framework.
Okay.
Like how you have your Spring framework, Struts framework, Hibernate framework, and you have JSF, Tapestry, Velocity, Turbine, like many other frameworks what you see. Hadoop is also a framework. It's an open source framework released by Apache, and this software framework is going to address your storage needs and your processing needs. Because every framework has got a purpose. You take a Struts framework, the purpose is to develop, manage, and extend complex web applications. Because the backbone for your Struts framework is MVC, that is Model View Controller Architecture. So your framework has got a theme there. Same like even this Hadoop being a framework, it has got the theme to address the needs of storage, large volumes of data storage, wide varieties of data storage, and massive parallel processing of the data so that the processing time can be drastically reduced. So Hadoop is a framework. In the other context, I say Hadoop is a product stack. I try to show you what other things you have as part of the Hadoop space so that you get the understanding. Let me take you over there. Yeah. So you can see this is what the Hadoop stack, entire Hadoop stack. You have the data storage, that could be your HDFS, HBase, and S3 from Amazon, NFS from MapR, CloudStore. And data processing, it is the MapReduce framework. And Hive is your query language to work on structured or semi-structured data. Because on a structured data, you always can execute your SQL. But on semi-structured and unstructured data, running the query is not possible. So Hive is a component which takes care of querying your semi-structured or unstructured data. And Pig is a data flow component. And Avro is a serialization format for your Hadoop framework. Mahout is a machine learning, and Scoop is a data connector. And Zookeeper is the management component to make your cluster highly available. Flume is the monitoring monitoring tool, and Chukwa, EMR, Uzi is actually the workflow or the scheduler for your, job scheduler for your Hadoop environment or Hadoop cluster. So this gives you the complete stack actually. This is a complete stack. So you can call it to be Hadoop to be a bundle with all necessary components to store, process, access, and manage your data, except doing the or implementing the data analytics. Data analytics been taken care with the specific tools. Your existing IT infrastructure for analytics. This is only for storage, processing, access, and manage. Yeah, please.
Srini, so we have Hive, and I see that you have put SQL in there. So
yeah.
Instead of SQL, any database can be used?
It is not the concept of database again. We call this as Hive query language called HQL, Hive query language or HiveQL we call it as. And this works only on your semi-structured and unstructured data that is stored on your HDFS. But if you want to connect to your database, maybe you have your traditional RDBMS, and from there you want to get the data into your HDFS, and your data in your HDFS needs to be exported to your traditional RDBMS. Then you have a separate component called Scoop. Using Scoop, you can import or export the data between your Hadoop cluster and your traditional RDBMS. And this Hive is to work on your HDFS actually, not on your traditional RDBMS. Because on the traditional RDBMS, you have always the SQL, the structured or the standard query language, which you always can apply and query the data that is there on your traditional RDBMS. The problem is how you query the data on your HDFS. For that sake, they developed something called Hive or HiveQL, which we call it as Hive query language, with which we can query the data on your HDFS. So is that clear?
Yes.
Yeah. So the discussion now that we need to start is how your Hadoop, your storage is going to happen and your processing is going to happen. So let me take a classical scenario from that. Shankar, I think you come with a rich experience in the industry. You imagine yourself that down the line after 1 or 2 years you decide to start your own company.
Okay.
And you start your own company. Maybe you have the vision that you already has got some product in the mind, or maybe some client has promised you that he's going to give the work. And based on that, you employed because you are going to actively work actually. So you have taken one more person to assist you because to have a quick start, you accepted the client work and you started your company, and with the help of this resource, you want to manage it. Okay, that is how you started the company. Maybe your luck or the performance what you are showing or the improvement or the quality of the work what you are delivering. The client is giving you more work. When the client gives more work to you, probably, I'm not saying that you are going to follow this one, this is one idea. Probably, you will not be making a decision to immediately employ one more person, because you never know whether he's going to continuously give the work or not. So probably your first choice is going to be, you ask your resource to work, for 2 more hours, and you are going to pay extra amount to him. I think that could be a reasonably good choice. You agree with me?
Yes.
And client is still giving more work. Maybe you can extend the same thing. You can ask him to work 4 hours more, and you are going to pay more. But interestingly, client consistently is giving more work. Then what you do?
Hire another one.
That's a good thing. It's a quite natural and a common thing. If you are able to understand this, think that you have understood Hadoop. Think that you have understood Hadoop.
Yeah. I know where you're going.
More work is being what I'm saying data. And one person is what I call it to be a node. And if data is coming more, I just add one more node. How you add one more person to your team? Same like you keep adding the nodes to your cluster, so that let any amount of data comes into your box. The only thing what you do is you keep on adding the nodes to your cluster. A node is just nothing but a machine which has got CPU, which has got your hard drive, both processing and storage capability. That is what I am calling it to be node, not just for storage. It will have CPU even. A node is just nothing but a machine, and more specifically, a commodity machine. It should not be a high-end server. I hope you understood my point, how my storage is going to be addressed. So this kind of concept is what I technically call it to be linear scalability. Linear scalability. So as and when you get more data, instead of you trying to store on a single machine, you are going to cut or you are going to break down your big data set into small pieces, and those pieces you are going to store on individual nodes. I hope you are following with me what I am trying to show. So your big data set, if you are not able to store it on a single machine, what you do is you break these into small pieces, and each piece you are going to store it on one machine. This is what I mean by a file system which is distributed across multiple machines, and specifically when it comes to Hadoop context, we call this as Hadoop distributed file system. Though your data is distributed on multiple machines, but it is being viewed as a single system through a single window, because there should be someone to actually manage all these nodes. Because you cannot go to every node and search where your data is located. There should be someone to actually address all those needs. That is what we call it to be a server, and that server is given a term called name node. And these nodes which are actually storing my data, these are technically called as data nodes. Every time you want to store a file, your name node is going to receive the request, and based on the size of the file, it is going to slice that file into uniform blocks, and those blocks could be of 64 MB or 128 MB or 256 MB or even 512 MB or even 1024 MB. Unlike your traditional file systems where the block size for your storage is 8 KB, your 64 MB is very big size. So this is what the fundamental difference between your traditional local file system data storage and the data storage on Hadoop. This is a fundamental difference. Unlike your storage on the local file system where the size of the block for your storage is 8 KB, the base storage for your data on Hadoop is in the form of 64 MB blocks, the base storage. And it can be configured to store the data in 128 MB blocks or 256 MB blocks or 512 MB blocks or 1024 MB blocks. 1 GB blocks. It is possible. So your big data set is going to be sliced into small blocks of this dimension, and they are going to be stored on individual nodes so that your data resides on. Now this is what. So your server knows very well for a given file where the data is located. For a given file where the data is located, into how many blocks the data is divided, and where those blocks are located, all those details will be maintained by the server. That is why name node is just called as a machine which preserves only metadata. It will not actually store any data. It will only store metadata. The information about the data, where it is stored, into how many blocks it is stored, where those blocks are located, only those details will be stored with your name node. But the actual data storage is happening at your data nodes level. That is where I say your Hadoop completely works on master-slave architecture. Where in terms of storage, my master is name node and my slaves are data nodes. I hope you are able to understand how my storage need is being addressed. It is a traditional example I give you. It is a very traditional example I give you. Maybe 5,000 years back, I'm talking about 5,000 years back, not 5 years or 10 years, 5,000 years back.
Srini.
Yeah, please.
Okay. I have a couple of questions before we go to the example. Right?
Yes.
So you said linear scalability. Right? So the linear scalability is done at real time, or is it determined at the time of the process?
That's a good and a classical question. See, you can add your data node at any point of time, even if the cluster is live in execution.
So
the cluster is linearly scalable. I give you a classical example for that. As of now, in Yahoo, you have, I don't know the exact number, but sometime back it was 6,000 nodes. Yahoo is running a live cluster with 6,000 nodes. I think by this time it might have definitely crossed more than 6,800 or 7,000. And this is expected to reach 10,000 in the next 1 year span, 1.5 year span. So nodes can be increased or nodes can be added to your existing cluster at any point of time.
Okay. And then the file size, the 64, 128, and 256, all these.
So that is not the file size. That is the block size. Your big file is going to be sliced into small blocks of this size. Yeah.
That's what I meant. So what determines that?
Yeah, because at the time of processing, each block is going to be processed individually. At the time of processing, each block is going to be processed independently and parallelly.
Okay. Yeah.
So that
what I mean is,
if my block size is 8 KB, yeah, please.
What determines the size of the blocks?
I didn't get your question exactly. Can you make it more elaborative?
Yeah. So, how do you know what is the what determines? What determines?
Fine. I understand. Yeah.
Okay.
That all depends upon the size of the average size of the files that you are going to store on your cluster, Shankar. Because you'll come to know, right? You'll be aware of the things in advance that at the time of storage, how you are actually getting your weblogs files or how you are getting your clickstream data, into what size the files are going to be usually. Based on that, you are going to decide whether it should be 64 MB blocks or 128 MB blocks or 256 MB blocks. And one other factor is, what is the level of the hardware that you are trying to set up for your Hadoop cluster? If it is a high-end hardware, then even if the block size is big, the processing time will be maintained, or the trade-off between your hardware and the average size of your files will decide what should be the right size of the block that needs to be configured at the cluster level in terms of storing your data.
So it's a configuration. So the person who is the architect has to dictate. Okay.
Exactly.
Okay.
Before we initiate the Hadoop project, we are going to decide what is going to be the average size of the data set that you are going to store on your Hadoop, and what level of hardware configuration that you are planning to set up your Hadoop cluster. And those two things will be taken into consideration to decide what should be the configuration for your block size for your data storage on HDFS.
Shankar, maybe actually you're confused between the linear scalability and the block size. Just like that, you're having your own laptop and you're having one hard disk in that. Suddenly at any point of time you get more data and you buy an external hard disk. Same way, any node can be added onto Hadoop when you have more data. It's just a backup kind of things. Towards the block size, if I take the example of 64 MB, for example, if I'm putting a 100 MB file, any file, text file or any file, if I'm putting 100 MB file onto Hadoop, Hadoop will divide this file into 64 MB blocks. One block would be 64 MB and the other block would be 100 minus 64, that is 36 MB. So in short, it will actually divide the files into these block sizes. If it's 128, then 64 block, it means 2 blocks will be there. If it's 128 size, then 1 block would be there. If it's 256, it's half a block is there. So these two blocks are put it onto Hadoop. I hope you're getting my point.
Yeah, I did. And I want to know whether it is divided by the operating system or the system itself.
No. That is going to be decided. No. That is going to be decided at the time of setting up the cluster. It is a cluster level configuration, not at the operating system level. Because your HDFS is actually a user space file system, but not the kernel level file system. Like your ext3 or ext2 or ext or your VFS. No, your HDFS is not the kernel level file system. It is the user space file system.
Got it.
This is a file system that is going to be created at your user space, not at the kernel level. It is not mounted to the kernel level. It is mounted at the user space level.
Yeah. So as an architect, you will decide what is the file. Yeah. Okay. And then the final question I have is the server, the name node or the metadata that is going to get saved in there. Right. So it looks like that is a very important, crucial component to. Suppose if we lose that or get corrupted, we pretty much lose all our data.
Yes.
So there's going to be a redundancy.
Yes. Because that makes your the blocks to be unused. Many blocks going to be unused because if your average size of your data sets will be something 200 MB or 300 MB, something like that, you keep bigger size blocks, then your blocks are going to be unused. So that's always the trade-off. That's all the trade-off between the average data sets that you are planning to store on your cluster and the hardware configuration that you are going to deploy for your Hadoop cluster.
So I'm asking if there's going to be a redundancy or another mirror server or something.
Yes. Now my next question is that one only. Suppose for any reason, if this node is down, because having 6,000 nodes on your cluster, one node getting failed is fairly acceptable. Even if one node gets failed, then the data available on that node is not available to you for processing, then your processing will not be complete, because the data that belongs to file 1 is on this node and is also on this node. When I plan to process my file 1, if this node is not available, my processing will not be complete. So in that case, what do you do? So I need to have even fault tolerance for these kind of things. So otherwise, that is the reason why you can see that one here.
Well, Srinivas.
Yes.
Isn't it that we have a multiple places that we save our same file? Like,
yes, that is what I'm about to share here. Okay. Your blocks are going to be replicated automatically on your cluster based on the configuration what you do at the cluster level. If you decide your cluster replication factor is 2, then every block is going to be replicated twice on your cluster in such a way that even if some node is down for any reason, your processing will not be affected. You see this slide, you can easily understand. For the file called foo, the blocks are 1, 2, 4. For the file called bar, the blocks are 3, 5. Now, these blocks are pushed onto your nodes with the replication factor 2. As a result, each block is repeated twice. Now, you just put your hand and you off one node and see whether your data is available completely or not. You put your fingers against one node and see whether all your blocks are available on the nodes or not.
No.
If my first node is down, 1, 2, and 4 are available in my second and third. See that. You put your fingers against the first node on the screen. My 1 is available on the third node, and 4 is available on the third node, and 2 is available on my second node. And my 3 and 5 are available on my second node. You agree with me?
Okay, so but there is only one replication instead of two replications.
Pardon?
But here we have only one replication, isn't it?
The question is not clear to me, unfortunately. Some background noise. Yeah.
All right. So there's only one copy being made over here, right?
Yes.
Okay.
Because for every block, there is one more copy maintained on the same cluster. That is the replication factor 2. But you can make your cluster to be configured with the replication factor 3 or replication factor 4, depending on your requirements.
Oh, I see. Okay, thank you.
So that way what happens, maybe you may get a question that if replication is there, then my storage is going to be more, redundancy is going to be more. But at the cost of the data, the importance that you give to the data, because your hardware is the commodity hardware, it will not be expensive for you to store your data in the replicated form, either factor of 2 or factor of 3 or factor of 4. Because it is not the expensive hardware that you are deploying to set up your cluster. I hope the questions are clear. The answers.
Okay. Can I take you back to the part where we have the blocks for 64 MB? I mean, 128 MB. Like these are something that we specifically, exclusively design on our hard drive, or anywhere that thing is stored, right?
Yes.
Okay, then from what I'm understanding, how is this? It's our job, or the computer or the Hadoop automatically assigns the file to this block.
Yeah, it is actually linked with your MapReduce. I mean, once you are done with this, then we go to the MapReduce, then you understand how these blocks are going to be processed by your MapReduce job.
Okay.
I hope you understand what I'm trying to share with you.
Yeah, I got a little better picture than what I had before.
Yeah. So you imagine a scenario that 5,000 years back, when our forefathers they are cultivating the lands, they used to use ox, right? Oxen. They used to use oxen. Never our forefathers tried to increase the size of the ox when the ox need to carry more work or need to perform more work. They never tried to increase the size of the ox. They never tried to make the ox to be more bulky or more hefty to perform, bigger tasks. Instead, they always added one more oxen to the existing to perform the job. You agree with me?
Yes.
Now you tell me whether the linear scalable model, what I'm talking now, is it new to this world or it is there from age old?
From age old.
I mean, even if you go deeper into Mahabharata and all, when they used to go to the war, you used to be in the chariot, and then it is being pulled by 5 horses, 6 horses, 8 horses.
So, okay, if we are,
it is the same implication that we are doing it here. If you are not able to store it on a single machine or a single hard drive, you are slicing it and storing it on multiple hard drives, so that they can be extended to the extent what you want. And as of today, you can practically say that this linear scalability can be extended even for our next 10 years needs. And by that time, you may get a new technology, and that is going to address your storage needs far ahead or far better. Yeah, please.
No, I think I got my answer now.
So you got your answer to the question?
Yeah.
That's good. This is all about my storage part only. Now, if you feel that I am done with my storage part, I can move on to my processing part.
Sure.
And my processing part is going to be something like this. In your traditional programming methodology or implementation, usually this is what is your application. And your application will be running on some machine, and your database is located on some other machine. This is what your database. Usually your database is been maintained on a different machine. Your application usually connects to the database, and your database is going to receive a query, and that query is being compiled. It has been parsed, compiled, and executed. As a result, you are going to give some response. This is what the request, and this is what the response. Now you observe closely. When compared to the size of the code, that is for your application, the size of the data present in your database is very high. Do you agree with my point?
Can you repeat that again, please?
When compared to the size of the code, the size of the data present in your database is far high. Usually the size of the code will be 40 MB or 50 MB or 100 MB or 200 MB. I am sure that your code never will be 5 GB, 10 GB, 20 GB. I am talking about the size of the application, size of the code. Hardly will be in MBs. It will not be in GBs anytime. I don't think in my career I have seen an application with a code of 2 GB or 3 GB. Never. But the size of the data usually runs in GBs or even TBs. You agree with my point?
What you're saying is the application processing, the data that process is far bigger than the code that we write to create the application.
Absolutely.
Okay. Yeah, that makes sense. That's always the case.
See closely. Your small size of code is trying to pull more data to its place and then doing the processing. Your small size of code is pulling more data from the database and doing the processing where the application is running. This is definitely expensive in terms of bandwidth, or you take any factor. I'll give you a classical example for this. This is what the big mountain you have. Rocky Mountain this is. And 150 kilometers away from this Rocky Mountain, you have set up a crusher, stone crusher, a stone crusher unit, where you put the big stones on this. It is going to crush into small ones, and this is what we call it to be gravel, and which is the essential component for construction industry. The mountain is 150 kilometers away from the crusher. So you need to transport the rocks along the way 150 kilometers to your crusher, crush those rocks and produce gravel, and you sell this gravel to the construction industry. You think it's viable? Transporting the rocks 150 kilometers from the mountain to the crusher is definitely expensive in terms of transportation. You agree with my point?
Yes.
Keeping this thing in the mind, you apply any technique. Can you pull the mountain to the place where your crusher is set up?
No.
Really not.
Beyond. It is always a good idea that you set up your crusher which is near to the Rocky Mountain so that your business is going to be viable. You set up the crusher which is near to the Rocky Mountain so that your business is going to be viable. I hope you are following with me.
Yes.
So I have two things here now. Pull the data and push the code. Which is effective? Pull the data and push the code. Which is effective? Push the code is always less expensive, right? Is always effective. And definite pull the data is also effective in the case where my application is going to take a username and the password, and it is going to send the request to the database. Please send me the password for this username. Then your database is going to send only the password for that given username. In that case, pull the data may be useful rather than pushing the code. So we cannot concretely say pull the data is the best all the times or push the code is best all the times. But in the context of big data, what we are discussing now, pulling all your data to one common place and process your data is definitely expensive. Pulling, because you have already stored your big data by slicing into small chunks on different machines. Again, from all the machines, you pull the data to one place, which is not possible actually. But even if it is possible, pulling all the data to one place and processing it there is an expensive thing. So, in this context, push the code is the best thing. So, for that reason, what I do is, as a developer, I am going to develop the job. That job is going to be given to the server, and that server is what we technically call it to be job tracker here. And this job tracker is going to push the same code. Job is nothing but the code. This code is going to be received by the server. It pushes that code to all the nodes where the data blocks are there for this particular data set. You may have 6,000 machines, 6,000 nodes. Your job tracker is not going to send the code to all 6,000 machines. It is going to send this code to all the machines where the blocks for this given data set are there. It is going to send the code to all those machines so that my data is there here and my data is there here. To this place, my code also will come, and this code is going to work with this. And when this code is running this data, this code will be running this data parallelly, because these are on independent machines, so that your data processing is going to happen parallelly on each node, which will not affect each other. If my data is located on 20 machines, on all the 20 machines, the processing is going to happen. I give you a classical example for this. I put 1 kg of food in front of you. I put 1 kg of food in front of you, and I ask you to eat that completely. It is for sure, it takes 1.5 to 2 days for you to finish that. But same 1 kg of food, I keep in front of 10 people to finish. In 20 minutes, that can be washed out. I hope you are following with me what I am trying to say.
No, not. Can you repeat it? Like I didn't.
If I ask you to consume 1 kg of food, hello.
Yes.
It definitely takes 1.5 to 2 days for you to finish that. But if the same 1 kg of food, if you ask 10 people to eat, they can finish in 20 minutes, in maybe less than 20 minutes, because each going to eat hardly 150, 200 grams, and they can finish this 1 kg of food in 20 minutes or half an hour or maybe 1 hour, not more than that. So where is 2 days and where is 1 hour? There is no comparison at all. Same technique is been applied here even to process your data.
And all these people have the same capacity.
Pardon?
They have the same capacity.
Yeah, obviously, because nodes are the same here. Because usually when you set up the cluster, nodes will have the same CPU power, nodes will have the same main memory, nodes will have the same I/O kind of thing, or at least similar, which is nearer. May not be exactly same, which is nearer. So they can finish in 20 minutes. Your 2 days activity can be finished in 20 minutes. You see the drastic improvement in terms of processing your data. So processing the data linearly, processing the data parallelly, if you understand that, then you appreciate how your MapReduce is going to actually process your data which is stored on your HDFS.
So Srini, the job tracker server, how that is connected to the name server?
Yeah, that's a classical thing again. So your job tracker is actually going to is going to get the information when you submit the job. When you submit the job, let me take you over there. Give me a moment. I give you an idea. Give me a moment.
Yeah.
So your job tracker is going to actually communicate with the name node to give the information. Your job tracker is going to actually communicate with the name node to give the information about for this file where the blocks are located.
Yeah. I got that. You know, you said the job tracker will know which code where it resides and which data it needs to process. So obviously, the name node which has the information has to somehow communicate to the job tracker this information.
Yes,
right?
yes. You are absolutely right, because all these belongs to the same. All these belongs to the same cluster. So getting the information or exchanging the information is not a big deal. Because your job tracker is going to get the information from the name node and requesting for this particular file where the blocks are located. For this particular file where the blocks are located, it will ask the name node, so that the name node is going to give the information regarding. I'm going to share that with you now. Give me a moment so that you get the fair understanding of how. Let me share that with you. Are you able to see my screen?
We are seeing the present. Oh, yes.
When the client is going to submit the job to the job tracker is going to communicate with the name node asking. It is going to communicate with the name node asking for this file one where the blocks are located. And your job tracker is going to push that code only to those nodes where the blocks are located for this file. It will not push the code to all the nodes. It will push the code only to those nodes where the blocks are located for the given file. Are you able to understand?
Yes.
So
I got the idea. I know, right, how the job tracker is getting the information and everything, right? Otherwise, it won't know, because we already know that name node is the one that keeping track of where and what resides, right? But
yes, exactly.
Yeah.
So when you are submitting the job, you are also going to specify what data needs to be processed. That is what the purpose of the job. You are going to specify what data needs to be processed when you submit the job. So based on that, your job tracker is going to communicate with the name node, and you will identify where the blocks are located for this file. Your job tracker will push the code only to those nodes, and the processing will happen only on those nodes, not on every node.
Okay. So the person who is writing the code or submitting the job, he should have some kind of idea about, not some kind of idea, he needs to know about what type of storage is stored, what type of data is stored, and where. In other words, he needs to know what the information in the name node.
Yes. So what the information in the name node is?
No.
That is.
No. The person who is submitting the job will know the information on name node.
Yes, will be there. That is, because you will be having the clear. Like how you are working with your file system. Same like you can work with your Hadoop distributed file system. Like how you are saying ls to list all the files present on your local file system on your Unix box. Same like you can find the files that are available on your distributed file system also with the command. Your HDFS is going to provide you the list of the commands with which you can actually see what files are present on your file system. And along with your command mode, you also has got the UI interface, web interface, through which you can browse the file system and you can identify what your files are, where those files are located, and in what path those files are there. I'm not talking about the block level. I'm only talking about the information present in the name node. That is always accessible. That is always accessible.
Yeah, got it. Thank you. Sorry to divert your attention, but
No, absolutely. Absolutely. I take it because this kind of interaction only will make more sense to actually work with your technology. I mean, it should not be a one-man show that I start with some concept, I keep going ahead, and after 1 hour or so, I will say my demo is over and you need to decide. That doesn't make any sense. So hope with all these things I was able to address you very clearly what is big data and how big data is related to Hadoop, and as part of Hadoop how storage is being addressed and processing is being addressed. So this is what I thought of sharing with you. How exactly your Hadoop is going to be, and as part of Hadoop what other components are there. I have already shown you in my previous slide. I mean sometime before, so that you as a part of your course you are going to work with these components, because these are not huge components. The major thing is your HDFS and MapReduce. Rest of all are small components. Your Pig, Hive, Scoop and all these are small components which will not take more than 2-3 hours on each. And sometimes if any issue specifically from your end not able to follow, we may extend the hours on specific component and more on demand. Now we see how those components can be. But those are small components which again heavily depend on your HDFS and MapReduce. So the course covers all the components, essential components that are required to be Hadoop. So I hope I have given you enough information to make you to understand what is big data and what is Hadoop and how things goes with Hadoop. Right? So you have any questions specifically other than our technical part, you feel free to ask me. But one good thing that I want to bring it to your notice at this stage, the market for Hadoop is exceptionally good and it is growing tremendously compared to any other technology. And there is a severe skill shortage in the Hadoop space, especially in US, and the same thing is also happening in India at this stage. And the skill shortage is at such a level where the companies wants to formulate a big data vertical, but there is no person who has enough knowledge to take the resources into the company. If I need to take the resources, first of all, I need to have a resource who knows big data or Hadoop so that I can interview the resources and take them and form a team. That was the bad state at this stage. So it was a story that I recollect. I know the things what I experienced before. I didn't give my introduction at all because I don't want to give the introduction before I take the demo or the discussion, because that's going to alter your perception. My introduction will alter the perception. I don't want that to happen. I want to have a true perception on my discussion. That's the reason why intentionally I haven't given my introduction. But when it comes to that, I started my career with JDK 1.0 beta. I don't know how many of you are there in IT that time. Away from the IT. This is my 17th year in the IT space. And before that, I was a hardcore C programmer. And later on, when Java been introduced to the market, from day one of Java introduction to the market till date, I was in the same space. And I've seen people who know how to write an applet, they were able to get a job. People who know how to write an EJB, they got a job. I mean, how the technology got evolved. And now it is a big ecosystem where, almost every IT landscape is directly or indirectly connected with the Java platform. So that rich experience made me to dive into the Hadoop space 3 years back. And I'm working on the same as an independent consultant on different levels. And training is actually an integral part of my activity all the years. and it gives me more energy and it gives me the real satisfaction, because I love to share the knowledge what I gain, and that's the motto behind handling the sessions. And I'm associated with Praneeth, not with the company where Praneeth is working. Praneeth was there with other people before. I was there with Praneeth almost last 3.5 to 4 years. So that's how actually the training initiation. That definitely makes sense for you to understand, what level of the Java backing that I have to dive into this one. It doesn't mean that everyone needs to have the similar backing of Java to enter into Hadoop space, because Hadoop has got wide variety of components targeted for different segments of people coming with different experience. You take Hive, that's suitable for the people coming from SQL background. You take Pig, people who are comfortable writing the scripts in Ruby or JavaScript or anything of that sort can easily cope up with Pig. And people who are extremely good with the querying part and database design and its layout and all can comfortably work with TechyBees, and good at mathematics and good at designing the patterns can take an option of working on Mahouse. So different components. So MapReduce is not the only way that you process the data. You have higher level of abstractions to MapReduce, that is Pig, Hive, and all these things, which makes your implementation more easier to achieve the same job processing on your Hadoop cluster. So that's what I thought of sharing it for the today's discussion. And you have anything specific that you want me to address, feel free to ask me so that I can attend on those things specifically.